All right, guys, happy Tuesday. It's Miss Lastly and Miss Markert here for day number 7, Arithmetic and Geometric Series. Get ready.
So today we are looking at arithmetic and geometric series. Hopefully this isn't too much of a step up from yesterday. It should be pretty easy still, hopefully. And so today we're just looking at finding partial sums of arithmetic and geometric series. So we're going to give you a couple formulas, talk about it a little bit, and then I have some examples worked out from the homework that we're going to go over. And that will be it. So hopefully it will end up being pretty short today. All right, so for just a quick review, partial sums are when you take a certain number of terms in a sequence and add them all together, and that's the partial sum of that series or whatever. And so yesterday your homework kind of walked you through some things and helped. It was kind of a guided notes section, so hopefully you did that. Okay, so today we are looking specifically at arithmetic and geometric series. So for an arithmetic series, we have a formula, and our formula starts with S sub n. Whenever you see S sub n, that means that you are finding a partial sum of a series, so that's kind of the notation we have for that one. S for sum, I guess, and then n is whatever term you're trying to find or trying to go to. So for this one, we have n over 2, a1 plus a k, or sorry, an. I have it written differently for some reason. So n is the number of terms you're combining. And then remember, a1 is just your first term, and a sub n is just the term number that you're going to. And this will give you the partial sum of your series. So if you have a series, say you have the evens, so 2, 4, 6, 8, if you want to get to, say, the 50th term, what this equation is going to do is it's going to add all the terms up from 1 to 50, and then your answer is that partial sum. Yeah. Cool.
Yeah. The only thing I would add is just make sure you know the difference between the symbols. So like Miss Markert said, S sub n, that stands for your partial sum. So that's when you're adding things. And then A sub n, that's your like term number, right? So A sub whatever, that's usually your symbol for your sequence. So A sub 5 is the 5th term, whereas S sub 5 is the sum of the first 5 terms, right? So just be careful with this formula because you have lots of them, right? You have S sub n on one side, you have A1, and then you also have AN. So just make sure you know your difference between your symbols there. Especially when we do some working backwards ones, which I'm sure we're going to go over because you have some on tonight's homework. It becomes really important to remember what each of those symbols stands for.
Yep. Okay. And those symbols don't change between arithmetic and geometric sequences. The only one that changes is that we use D for the comma difference for arithmetic sequences, and then R for the geometric sequence or series. It doesn't really matter. So S sub n, A sub n, A1, those are all the same between the two. So make sure you have those straight. Okay, so then for our geometric series, we're going to look at finding the partial sum for a geometric series, and then we're also going to look at how to find the infinite sum of a geometric series. I realized that I took that problem off the homework on accident, and I went back and added it back in. So if you were doing the homework before this morning, maybe go back and look at the problem that changed. I think it was number 3, just to make sure that you know how to find the infinite sum. But yeah, so again, we have another equation here. So our equation for this one is again denoted with S sub n. and this is equal to A1, 1 minus Rn, R to the n, sorry, and then 1 minus R. And remember, R is your common ratio, and again, A1 is just your first term. I'll write that up here. And remember that R is just your common ratio there. So again, this will give you the sum of whatever terms you want. Okay, so then really quick, we have one thing to go over. So we have to look at how to find the infinite sum of a geometric series. And what this tells us is when the absolute value of R is less than 1, we have a convergent series. And the limit when n goes to infinity is equal to a. And so this is going to tell you the sum of your series, and that's what your series is going to converge to. And you use that formula right there, and that's what your series is going to converge to. So on your homework, it asks you to find the partial sum of a geometric series, and if possible, find the infinite sum. So you are asked to find both when the infinite sum is possible, because we do give you a term number that we want you to find the sum of. And the infinite sum is kind of a separate thing. It just tells you what the whole series converges to, and you just use that formula. For arithmetic series, we don't have a specific formula for that for the infinite sum, and you don't really have to do anything with it, so I kind of just skipped over it. But if you have any questions about it, you can always ask in the discussion board, but you're never going to have to know after this class. So
yeah, well, I mean, for arithmetic sequences and series, I mean, there is no infinite sum, right? If you're taking a number and you're adding or subtracting to it every time, it's never going to approach a single value. Remember, when we say something converges, we're saying it's approaching a single value as the term numbers go to infinity. The reason why it works for geometric series is because when you multiply by a fraction, you actually are making your number smaller every time, right? If you multiply 2 by 1/2, it becomes 1. If you multiply 1 by 1/2, it becomes half. So when you multiply by a fraction, which is what the rule says, right? If your common ratio is smaller than 1, meaning it's a fraction, then your number is going to get smaller and smaller and smaller that you're adding every time. So even if your number started at 50,000, if every next term you're multiplying by some fraction, the number that you're adding to 50,000 is going to continually get smaller over time. So eventually you're adding the fraction 0.00000000001, which isn't really going to change the sum of your sequence. So you can say that you do have some limit to your series. So it doesn't really apply for arithmetic because that's going to be an infinite series. You're just going to keep adding numbers for forever, and it's just going to keep getting bigger or getting more negative depending on which direction you're going. But not with geometric, right? Because you're multiplying, and if you multiply by a fraction, you end up basically adding 0 to your problem every time, which means it's going to converge to some number. And from last night's homework, if you looked at problem 8, it was kind of getting you to like see this coming, right? I think it was 7 and 8. 7 had like listing out the first like 200s, like the sum of like the first 10 and the first 20, then like the first 200. And you could see that eventually it was approaching just one value. And the reason is because your common ratio was a fraction. So that's just geometric series has that cool kind of effect where sometimes it does actually converge, which seems counterintuitive if you're adding something every time. But it works out that way.
yes. Yes. So basically, arithmetic sequences converge to either infinity or negative infinity, because you're always getting bigger or smaller. Mm-hmm. Yes. Okay. So those are all the formulas that you need for tonight's homework and kind of all the concepts that you need So let's look at the homework. Okay, so I was debating this morning which ones I was going to do, and I think I'm just going to do the first two, and then I'm going to do number 6, so a backwards one. So number 1 is a geometric series. So yeah, let's jump right in. Okay, so for this one, we can see really quickly that r is equal to 5 because 2 times 5 is 10, 10 times 5 is 50, and so on. So r is equal to 5, and we're asked to find S11. So first, we need to find our explicit equation. So let's just write that really quickly. So an is equal to 2 times 5n minus 1, just so we can kind of see what our sequence is. And then to find S11, we're going to find 2, 1 minus 5 to the 11. So remember, it's your first term, and then 1 minus your common ratio to whatever term you're trying to find, and then over 1 minus your common ratio. And that one is equal to 24414,062. So the sum of the terms 1 through 11 is equal to that really big number. Yes. So you can see why we would have a formula for this, because trying to do this by hand would be really gross and disgusting. Okay. So then our second problem here is an arithmetic sequence. And drop my pencil. That's okay. So this one's an arithmetic sequence. So we're using D because we have a common difference. And our common difference for this one is 7.6. So if you take the second term, subtract the first term, you're going to get 7.6, and then it's the same throughout the whole series. And our explicit equation for this one is 7.6n plus 16.4, just so we have it. And then S sub 54, so remember you're finding the partial sum, so you're finding terms 1 through 54 added all together using this equation. So we take the term number, so 54 divided by 2, and then you take 24, yep, the first term, so 24, plus a k, which is the term, the nth term. So this one is 426.8, and this is equal to 12171.6. Just like that. So it's a lot of just plugging in stuff and then solving.
Yeah, so just remember the two formulas are kind of different in how they work. So with geometric, you don't actually need the explicit equation. You don't need to write a sub n, just because you don't really need it for the sum formula. But if you look at the arithmetic equation, you definitely need to know what the explicit formula is, because to get that 426.8, we had to take the explicit equation, plug in 54, because that's our nth term, and because we needed that for our equation. So just kind of pay attention to that, especially when we do like a work backwards one. You need that explicit equation.
Mm-hmm. And that was equal to 4. Okay. So those were the two that I was going to do for that one, and then I'm going to work through one work backwards one really quick. And I picked number 7 for this one. So we're just going to work through this one really quick. And I'm only going to work through one of these because you only have 3 in your homework. So you have 2 chances to practice. So for this one is a geometric sequence. If you look at these, we can see that 26 divided by 13 is going to end up being 2, and so on. So when you take your second term, divide it by your first term, we're going to get 2. I've already worked through these, so I already know the answers, so I'm just going to write r equals 2 there. Okay, so for this one, Remember, we don't really need a sub n for this one, so we don't need to find it. Remember that when you're working backwards with the arithmetic one, you do need a sub n, and that will be on the answer key. I will probably write out some notes for you guys on the answer key, so make sure you look for those. Okay, so for this one, we're going to take S sub n. So remember the S sub n is equal to 425,971. So we're going to take that right here. 1, and we're just going to set that equal to our equation for the partial sum, and I'm going to just plug things in here. So we're going to have our first term, so 13, and then 1 minus the common ratio to the nth power over 1 minus the common ratio, and now we need to solve for n. So the first thing we need to do is get rid of that 1 minus 2 on the bottom, so we're going to multiply both sides by 1 minus 2. That's going to cancel, and we're left with negative, 971 on that side, and then what was on top on the other side. The next thing we need to do is divide by 13, and we're given this gross number, and then 1 minus 2 to the n. And then we're gonna subtract 1 and then divide by a negative on both sides, just because we can. So we're left with 32768 equals negative 2 to the nth power. And then we're gonna divide by a negative just to make it nicer, 1. So these change to positive. And then remember, for this one, we need our exponential and log properties. So remember that this is going to end up being log base 2 to 32768, and then that's equal to n. And when you plug that into your calculator, you should get n is equal to 15. So what this means is that the really big number that it gave us at the beginning, so 425,971, is the partial sum of the first 15 terms of that sequence. So that's what you were finding there.
Yep.
Yep.
All right, guys. Well, I think that is it for today. Definitely try these ones on your own. We tried to kind of reduce the number of problems on the homework because I know you guys have a lot going on outside of school, but please, the ones that we kept up here, we definitely want you guys to try. But yeah, we will see you guys again tomorrow for some more practice.
Yes.
Bye.